And the sound is of course coming from the MIDI 80 you hear whenever I
microtronic computer. My voice is an L2. I am a microtronic computer system. I am a microtronic computer system. This is my basic program. It is as simple as it gets. Hello. I am LambdaMikel. Soft and gem software correctly present run in space. Hyperspace exit at Sol 3. Hawaii Hasili Sagan Dear Elfin. Defects in Sersi Eric Susan. I search from Amstrad. I am making taking and using the original SDO256 AL2 chip. This is the original BK-tronics speaking SI server SX extension. All systems are functional.
where nobody dared to go. The love that we came to know, they call it Xanadu. A million lights are dancing and there you are, a shooting star. An everlasting world and here with me eternally. Xanadu, Xanadu, in Xanadu.
TikTok version 2.0 is running. Hello there. I am connected to the legendary TikTok speech synthesizer. I am a new speech synthesizer for the TRS-80. Hello, I am Cover 80. Nice to meet you. What's your name? Hi Mike, thanks for purchasing me. And now, I would like to sing a little song for you. Made of TikTok mode. Happy birthday, dear TikTok. Happy birthday. Roughly AS100 emulation is working now. Thank
Hello,
you.
Tandy, TRS-80 enthusiasts. Happy September, the month in which we are celebrating all things Tandy. This is my clocked at 16 megahertz, so this is a crystal. Address locations only. So let's make sure, let's check if the program got transmitted. So I'm address 8000 and you see what it does. Also here in the breadboard area for display and so on. Next generation emulator. So we are saying no here. Let's remove the delay again. Next speed. How compact I can make it actually. It should be quite compact. Module, and it sounds really great. Here, then there will be one slot. This LED here is basically the clock wire, right? And register 0 on the display, and then this is the data input.
prepare yourself, programs, as you are going to meet the wrath of the MCPC. You're in trouble, program. Very disappointed in you.
Great job. The CPC is free again. Thank you so much.
Use the cursor keys in order to get to that point, so take some thinking. And I mean, the speed is what you expect from the machine. Alright friends, here's the basic demo. Internet connection. Rather it has an SD card with a quote and with the quotes. And it also is an MP3 player, so you can... And then we basically have an audio amplifier. Hello retro computer fans. Force, don't have, and go. Use the stop token to... I need to put in one more label for the tone. No, it's actually longer than 20 lines. So the lower, oh god, so the file name is already correct. It's about 6 seconds. Leo Brody from Force. So this is of course 126. So, I should mention one more difference, right, to the make in the Brody book, right?
This is the real voice of the Epson HX20.
Image quality is actually quite good then. And originally, of course, the Atari had only RF modulator TV output, so I modded this to output composite video. Right, and there's Pac-Man, right? But look at this Pac-Man, right? So this is actually a very fun port of Pac-Man, very decent. So they definitely had very talented and skilled developers and programmers for Naboo working, right? Alright guys, that's it for now. Max CPU frequency 9. So the BIOS reset works in some cases with the chord, right? Simply over the data, basically. The BIOS recognizes the chord. In many cases it doesn't, and then you really need the physical reset key, right? It holds, right? This is the same spacing that was the connection to the motherboard is established using another connector board, right? Where is it? On the microtronic. Within 1 second it loaded, and now we should have our program back at address 1800, and there you go, operations, and finally the hold. All good. So let's start the program. For this we have to load 001 into the program counter, right? And then we can either single step through the program or we can just hit run. So let's be brave and courageous and simply hit run. And there you go. We saw 6 for a little bit over a second, right? Basically in one, and now we add another one. I've prepared a little extension of this program, right? And so this is my re-implementation of the microtronic, right? You can find the project on GitHub. So that's the maximum nesting depth of the recursion. But let's run it for 3 and see what we get. 1 from A to C, which is surprising, right? 2 from A to B. And the oscilloscope can also tell us the frequency, but at least that gives us now our first number. So 114 instructions per second, and then we hit run, and wow, there we have our square wave. If we do this, 643 times 5 is 3115 instructions per second, right? So, and what does the oscilloscope tell us? Alright, I zoomed in a little bit so that we can observe the oscilloscope a little bit better and what it shows us. So we see that the machine runs at 217 Hertz, right? And yeah, we are executing a program that takes 2 instructions, right, in order to reproduce this square wave. So I would claim that we multiply this by 2 and that the machine executes at 434 instructions per second. Alright, so there we have our square wave. It actually says 29.4 kilohertz, so 147,000 instructions per second. Subroutine, and it basically does the same that the microtronic would do with its background swap exchange operation by bringing the background registers into the foreground and vice versa. Right? It is from source to target, and now we have to make the second recursive call. So yeah, let's just start it at address 1800. And I also observed that I didn't get a clearly defined logic low level. I cut that here, and then I'm putting basically the Dupont via here, the data. And so the data arrives here in the serial monitor. Move disk number 1 from 2 to 1. Alright. So you will say, okay, but what about disk, right? I got from Steve, fully assembled. Right? driving this blue LED display.